Hello students. Since I didn't get the opportunity to discuss this with you in class, I quickly wanted to go through 9, 10, and 11 because these are fundamental concepts that you have to understand. So we're talking about operations on functions, and this is where we combine this function notation with our basic operations of add, subtract, multiply, and divide. When you see this symbol right here with parentheses f minus g parentheses x, what this is saying is you want to subtract the functions f and g of x. In other words, it's simply taking f of x, or the function of x, and then subtracting from it the function g of x. That's what that means. So f minus g is just the difference, or the subtraction of the two functions f and g, and both of those functions are of the function x, meaning my input variable, right? If you look, your input variable is x, right? So to get f minus g of x, really all you have to do is take f of x, which is your first function, 1 over x plus 3, minus g of x, which is 5 over x minus 2. Now, ideally, we want to be able to put these together, right? Combine like terms and all kinds of good stuff like that. So ideally, we want to get a common denominator. And so that means I'm going to multiply both of these quantities to get a common denominator. And so this guy here, the second one, you're going to have to multiply by x plus 3. And if you do it to the denominator, you have to do it to the numerator. And on the first one, this one, I have to multiply by x minus 2. And again, if I do it to the denominator, I have to do it to the numerator. And so really what I have when I subtract is I have x minus 2 over the common denominator, which is x minus 2 times x plus 3. And then minus, and then over here on this side, I have 5 times x plus 3. All over that same denominator, x minus 2 times x plus 3. Okay, so if we're continuing on, right, let's just do it right underneath. I don't leave a lot of space here, but I was trying to conserve some paper, and that's okay. We can just do it right here. We'll just make a little space here and get in here. So what are we trying to do? Right here, what we're trying to do is we're trying to combine these two fractions together. So we got like terms, and we have to be really careful. So now that we have the common denominator, we can just put them all together, right? X minus 2 times x plus 3 is my denominator. And my numerator, well, the first part is x minus 2. The second part you have to be very rigorous about. That's negative 5, and that's getting multiplied through to each of those inner terms on the x plus 3 quantity. So that's minus 5x minus 15. And so if I'm going to put this together and simplify, really f of x minus g of x, which is the subtraction of those two functions, winds up being minus 4x minus 17 all over x minus 2 times x plus 3. Nothing factors out of the numerator, and therefore this rational expression is reduced as far as it can go, and you just stop right there. So this actually represents the difference of the functions f and g, or f minus g of x. Okay, so let's move down to the bottom one then, and on the bottom one you're asked to look at fg of negative 1. And another way to think of fg of negative 1 is this is f times g, right? This is the product of the two functions f and g. So this is the product of the two functions f of x and g of x. But these are being evaluated, right, at x equals negative 1. That's what this means right here, right? Because the negative 1 is inside, it means we're actually plugging negative 1 into my product. So we're finding f and g, and then we're taking a product, we're multiplying them, and then evaluating at negative 1. Some people actually do it the other way. They first of all find f of negative 1, and then they multiply that answer by g of -1, and that's also acceptable. So you either find the product f times g, then substitute -1, or you find f of -1 multiplied by g of -1. I'm going to go with this since I already have it started here. And remember, when you're putting that -1, it's not multiplied, it's actually substituted in, right? Plugging in. We're evaluating at -1. So f of -1 is just -1 minus 7. And that is going to get multiplied by, and so I'm going to use my parentheses because I have a combination of things going on here, quantity. I'm going to multiply that -1 minus 7 by g of -1. And g of -1 simply means I'm going to plug -1 into the function g. So I'm going to take 2 times -1 plus 3. And so now I'm simply going to simplify this down. -1 minus 7 is going to give me -8. And I'm going to multiply that by the quantity over here, which is -2 plus 3. -2 plus 3 just gives me 1. And so it's -8 times 1, which is -8. And therefore, I would say that -8 is the solution when you have f times g of -1. Beautiful. So that brings us down to composition of functions. Composition of functions is probably one of the most used operation of functions in calculus. What happens when we compose or take a composition of two functions? This is when we plug one function into the other. And in this case, the order really matters. The symbol, this open circle symbol means compose, right? That's the symbol for composition. And what it means is plug in. And so in this case, the function that sits closer to x is the one I'm plugging into. And so f composed with g of x is thought of to be plug the function g of x into the bigger function f, or f of x, right? And so that's really what we're doing in essence. We're plugging one function into the other function. In math, we denote it as follows: f of g of x. So I'll just write that down. This is f of g of x, right? And that's what it means. Take g, plug it into f. So we're taking f of g of x. Beautiful. So in this first example, we have f of x equals 8x plus 3. G of x equals, x to the fifth. And we are asked to find two things. The first thing is f composed with g. So f composed with g is simply taking f and plugging the function g into it. And so visualize it. You're taking g, which is this guy right here, and you want to plug him into f. And so sometimes this helps with the notation. Let me write that down. What am I plugging in? I'm taking x to the fifth, right? And I'm plugging it into the function f. And so that means I'm plugging it into f, which means I'm putting it in place of the x. And so what do we get? F of g of x is f of x to the fifth, and that's just 8x to the fifth plus 3. And that is f composed with g of x. Beautiful. Okay, let's do the opposite. G composed with f of x, and I'll do it right here. G composed with f of x. Now this time, f is closer to x. That's the thing we're going to plug in. So this time, f is getting plugged into g. So go back to your thing, and so what do you say? What is f? F is, let's see, what is f? F is this guy right here. F is this guy right here. So we're plugging f into g. Well, let me write that out. So that means I'm taking f, which is 8x plus 3, and I'm substituting it into the function g. And so that means I'm going to take 8x plus 3, and I'm going to raise it to the fifth. And that is g composed with f of x. Composition plays a critical role in calculus, so make sure you do a lot of practices with these, okay? All right, but that brings us down to the next problem, which are also compositions. This time I have two functions. I have h of x, and then I have L of x. And so the first thing we're asked to do is find h composed with L of x. So I have h composed right? The L is closer to the X. So what we're doing is we're plugging the function L of X into H. So where is L of X? Here's L of X, and I want to plug that into H. So I'm going to plug into H the entire function, negative 8x plus 1. And that's going to get plugged into H, but H is 1 over X. And so can you see that we're taking an H of negative 8x plus 1 is just 1 over negative 8x plus 1. And this would be H composed with L of X. Beautiful, beautiful. Let's do L composed with L of X. Now this one's a little trickier. And the reason this is a little trickier is because we're composing a function with itself. In other words, we're plugging the function L into L. Well, let's see. What does that translate down to? So we're plugging L into L. What is L? L is negative 8x plus 1. And we are substituting this into the function right here. And when you substitute it in, you put it in place of x, right? So let's see. That becomes negative 8 times, and this is where we're plugging it, right? Negative 8x plus 1 plus 1. Oh, and I can simplify that down a little bit. That's going to give me, I'm going to distribute, right? That gives me 64x minus 8 plus 1. And that gives me one more step over here. So that means I have 64x minus 7. This is composing the function L with itself, or taking L of L of X. So that brings us down to the final problem of our worksheet, which is F, which is in blue, is a linear function, and G, which is in red, is a parabolic function. We are tasked to evaluate each of these different elements here, and notice they involve compositions and they involve additions and division. Alrighty, so the very first thing I want to do is I want to deconstruct this. When I have, when I have F composed with G of 2, what am I asking? Well, remember, composition is plug a function into a function. So what I'm really asking is, I'm asking what is F of G of 2? And so now we have to be really rigorous and go step by step. All right, so G of 2 means what is the Y value when X is 2, right? So when X is 2, what is the Y value for G? So we go over to our graph and we look. So when X is 2, which I think is right here on my X-axis, remember our domain is across the bottom. So when X is 2, notice the Y value, isn't that just 0? Isn't it corresponding to 0? It is. And so G of 2 is just 0. And so that means I am looking for F of 0. That's what I'm being asked to find right here. F of 0, because that's what G of 2 is just 0, and so I'm looking for F of 0. Okay, so now I have to go to the blue curve, and I look. When X is 0, so when X is 0, what is its corresponding Y value? What is F of 0? So we go over here. When X is 0, what is the Y value? Notice that puts me right here, and so my Y value is actually negative 1. And so we would state that, okay, good. Here we go. F composed with G of 2 is going to give me negative 1. All right, let's do the same thing with the next guy. I have G composed with F of 2. Starting on the inside, this means we're going to plug F of 2 into G. Now, F of 2 is my blue function, and I'm taking X being 2, my X value is 2, and so I'm asking what is the corresponding Y value, right? That's what we have to first start. F of 2 means what's the Y value when x is 2. So when x is 2, I'm right here. And what is the f? F is right here. And what is the corresponding y value? The corresponding y value actually happens to be 1, right? 1. So what we're going to do is say f of 2 is 1. So I am going to have this equals g of 1. The y value when x is 2 of f is 1. And now we're going to go to our red function, right? G of 1 says when x is 1, what is the g value, the y value, when x is 1? So let's go to x being 1. Oh, look at that. Look at that. It's right here. And what happens to be my y value? Notice my y value is once again 1. And therefore, we would say that g composed with f of 2 is 1. Let's continue along this logic. Let's go f composed with f of 2. Alrighty, so here we go. F composed with f of 2. So I've got f composed with f of 2. So what is this? Plugging f into f, right? So I'm taking f of 2. Now, f of 2 is my blue function, and I'm saying when x is 2, what is y, right? That's what that means. So when I go to 2 and I see x, what is the y value? My y value is 1. We just did that a second ago, right? So that means when x is 2, f of 2 is 1. So now I'm looking for f of 1. So again, I have to go to my blue graph, and this time I'm saying when x is 1, what is the y value on f? So when x is 1, oh, heck. Nope, wrong curve. I was looking at the wrong curve. Let's try that again. When x is 1, I'm on the blue curve, right? Whoa. So if I'm x1, I'm on the f curve, which is the blue curve. Notice it hits right here. So in fact, that looks to be 0 to me. So it looks like f composed with f of 2 is just 0. Oof. Alrighty, we're getting there. So now we've got g composed with g of 2. So in other words, we're going to take g of 2, right? We're going to plug g of 2 into g. So again, we're focusing this time on the red curve. So when x is 2, we want to know what is the corresponding g value or y value. So when x is 2, notice I'm right here, and so the y value is just 0. And so g of 2 is just 0, right? G of 2 is just 0. And so that means to finish the problem, I now have to take g of 0, which means when x is 0, what is the corresponding y value in terms of g? So when x is 0, the g value is all the way up here. It looks like my g value is 4. So I think g of 0 is actually just 4. Now, composition's tricky when you're talking about a graph. The last two are going to be a little simpler, I think. I'm going to do one over here. F plus g of 4. F plus g of 4. F plus g of 4, what does that mean? F plus g of 4 means I'm going to take the two functions f and g and add them up, right? So in other words, I'm looking for f of 4 and g of 4. And what is f of 4? Well, f of 4 is asking the question when x is 4, what is y, right? And g of 4 is asking similar question when x is 4, what is g? What is the y value for g? For f, it's the blue curve. For g, it's the red curve. So let's see. F of 4 means when x is 4, when x is 4, what is the corresponding y value? And so if you notice, your corresponding y value is just 3. And g of 4, well, let's go to 4 again. And this time, let's figure out, oh, we're up here this time on the red curve. And what is g of 4? G of 4 is just 4. Sorry about that interruption. And so where were we? So we have 3 plus 4. And so f plus g of 4 is just 3 plus 4, which is just 7. So we would say that the sum of the two functions f of g when evaluated at 4 just gives us 7. All right, very last one. F divide G of 2. F divide G of 2. In other words, we're looking for the division of the two functions f and g evaluated at 2. And we can dissect this and look individually. So that means we're taking the function f, evaluated at 2, and then dividing it by the function g, evaluated at 2. And so let's go piece by piece, remembering f of 2 is my blue curve, and it's asking when x is 2, what is the y value on the blue curve? So let's take a look. When x is 2, I'm going to go on my blue curve, and it looks to me like the y value is 1. So f of 2 is just 1 on top. G of 2, well, that's my red curve, and I'm saying when x is 2, what is the corresponding y value on the red curve? So when x is 2, notice I'm right here at the bottom of this parabola, so what is my y value? My y value here is 0. And so what do we get here? We get 1 divided by 0, and we know we can't divide any number by 0, right? That's a no, absolutely not. And so when that occurs, that's when we have to write this symbol DNE, or does not exist. And so let me just fill in. F divided by G of 2 is does not exist. F plus G of 4 is 7, and I think we have finished this problem. And the worksheet. Great work, guys. Great job. You guys work really hard this weekend, okay? I don't care which module, but pick a module and just work it through, okay? Practice the problems, and if you need me to reset, just send me an email. Okay, good luck, everyone.